So warm-up says add fractions. Well, the rule for adding fractions is you need common denominators. If you have common denominators, it makes it really quick. Right here, they're both 13, so 2 plus 24 is 26 thirteenths. However, whenever we have a fraction, we always want to reduce it, right? And in this case, this one, you can divide each one by 13, and you end up with a fraction 2 over 1, which can be written better as 2. I'm going to recalibrate this. Seems like I have to do that more and more lately. Okay. So the next one, we can't just add them straight across because they do not have the same denominator. So a quick way to do this one needs a 2 and this one needs a 7. So I'll multiply top and bottom by the missing term. So if I multiply that by 2, I end up with 6 fourteenths plus 35 fourteenths. And then when I add them together, I get 41 fourteenths. And 41 doesn't have any factors that 14 has, so it's reduced as far as it can go. So what happens when we throw variables in? Well, nothing. The rules still stay the same. We still need common denominators, right? So in this case, I've got a 13 and an x, so it's going to stay 13x, and then the numerators are exactly the same as the first problem we did. However, we're not done with that answer because we can still think of this as 26 over 13, and that reduces down to 2, just like the first one did. However, there's a difference here. The x on the bottom has to stay in the denominator. So 2 over x. All right, my rule for multiplying. What do we do when we multiply fractions? Multiply straight across. Okay, we could write that better as numerator times numerator, denominator times denominator. What I usually do is just, actually there's a trick here. I'll show you in just a second. But some students do this and say, okay, well 4 times 5 is 20, 7 times 2 is 14. But we run into a small problem there because that fraction is not reduced. So then I can divide each one by 2 for sure. And I get 10 sevenths. However, I think there's a better way to approach a problem like this. So it's up to you if you want to write this, but watch what happens here. Since we're going to be multiplying straight across, this was 4 times 5 and 7 times 2, right? They're all joined together. Well, notice how I divided by 2. The reason why is we have a common factor on 2 on top and on bottom. So before we multiply, if there's a common factor of 2 on top and on bottom, I'm going to reduce that right away. So really, up top I have 2 times 5, which is 10, and 7 times 1, which is 10 sevenths. It's already reduced. In my mind, that's a lot faster, and that's actually the approach we're going to be taking today when we have variables. Now, let's take a look and let's follow that idea with this next example. Before we just multiply straight across, do you see a common factor that they share on top and on bottom? What's something that the top shares with the bottom? An x. Right there, they each have an x, right? So let's get rid of the x's. An x over an x is going to reduce down to 1. And what else do they have? A 3. We can divide by 3, so then there's a 2 left over. So this is 2 times 2, which is 4, and all that's left in the denominator is 5. All right? So, what we just hinted at is these same rules you've been doing since you've learned to multiply and add and subtract fractions are going to apply to today. But what I showed you with these last 2 examples here is if you can have a factor on top and a factor on bottom, they can reduce out, and it makes it a lot easier to go. So, that's actually where we're headed. Quote for today: if you watch how nature deals with adversity, continually renewing itself, you can't help but learn.
Oh, wrong room.
Good morning. All right. Really quick, before I even talk about what we're doing today, I just want to add a quick little point. So we only have a couple weeks left. I think I actually might have thrown this in here. Oh, I didn't. Maybe I'll show you a calendar here coming up. But we are starting the last new unit of the school year, and we're going to spend 2 weeks on it. So last Friday, you had a test. Just at a quick glance, I had about 5 to 6 people in this hour not take that test yet. So if that's you, that's a priority tonight to get that done. I want to make sure that I haven't graded that yet. So that's on my goal tonight, is to finish grading that and get you guys up to date. But I just want you to be aware that that might be missing. If I have time, I'll just put it in as missing, and then you guys can see who you are. But you should know if you didn't take the test last Friday. So get that in. And then with our new unit, the last unit is operations. When we say operations, that's your standard operations: add, subtract, multiply, and divide. And we're actually going to do all of them today. The nice thing is your rules for fractions, add, subtract, multiply, divide, don't change. The only difference is it looks more challenging because we have polynomials in numerators and denominators, and we call those a rational expression. So think of the word rational real quick. Just so this isn't just a brand new term, what if I just look at that word, ratio? A ratio is comparing two quantities, a numerator to a denominator. So when I see the word ratio, I think of a fraction. And when I think of rational, it's fractional expressions. So we're going to start with this. And I apologize, this, again, didn't appear as big as I thought it was going to. See if that's a little better. So our goal here to start off is, since we're dealing with rational expressions, since we're dealing with fractions, we have to know when they're simplified. Just like we did in the warm-up, we have to simplify when possible. I don't think you need to write this definition, but just so you have it on here, a rational expression is completely simplified when the numerator and the denominator have no common factors. All right, so same thing you know about simplifying. Let's just work through 2 problems really quick on how do we simplify. And I'll just leave you a little hint. Leave yourself some room to work above these problems today. That's the approach we're going to be taking. So if I'm asked to simplify, and I don't want any common factors on top and on bottom, that means I have to take the expressions that are given and we have to factor them. Just like we did in chapter 4, which you may have not been really strong at factoring when we first learned it, but notice how we just keep using it over and over again. A lot of the work today is going to be the box with the circle in it. However, it starts with an a value of 1. So we're thinking and hoping most of these you can do in your head. So we don't want to show a ton of work, but let's think of factoring the top. What are factors of positive 10 that add up to give me 7? Perfect. So x plus 2, x plus 5. Now, I really hope that you're going to be super strong with this bottom one. Remember how this has a missing term? You don't have to write this step right here, but this is what I think. If I just have x squared minus 4, that's 0. The middle term is 0. So now I'm thinking, well, what 2 numbers multiply together to give me negative 4, but add up to give me 0? X plus 2, x minus 2. Now that looks kind of messy, right? So if you want to, you can think, all right, well, I changed the appearance of this so it's in factored form, and I changed the appearance of both of those so it's in factored form. Now let's compare top and bottom. Do they have a common factor in top and on bottom? Well, it's going to reduce out is an x plus 2 on top and an x plus 2 on bottom. And our new simplified answer is written whatever's left in the numerator over whatever's left in the denominator. And because there isn't any other pieces, you could leave it like that. Or you could put parentheses around it, showing that those are just both factors. Doesn't matter. So that's using that idea of those two you could have done with the box with the circle in it. These two, technically, we don't use the box with the circle in it, but we can still factor. We were looking for common factors, so I need to reduce the bottom. Well, I'm thinking here, okay, well, what goes into 21x squared minus 105x? We're going to pull out the largest common factor here. So here's a hint. 21 times 5 is 105. I'm going to actually pull out a 21, and then notice how each term has at least one x. So I'll pull a 21x out, and what's left over is x minus 5. Now the top part, that's technically already simplified, but I have common factors in top and on bottom. This one x right here is we're going to reduce out with one of these. So I'm going to cross this out, but it doesn't go away. It just means an x squared. But then we think of the numbers. Just look at what we call coefficients. 7 over 21. They're both divisible by 7. So I'm going to get rid of a factor of 7, which if you want, you can put a 1 there. And then 21 is divided by 21 divided by 7 is 3 4. Now, what's left over then is just a 1x squared over 3 times x minus 5. Okay. Now here's one very common mistake. When people look at this, they see this x right here, and they see the x squared, and they think, oh, there's an x on top and there's an x on bottom. It has to be a common factor for it to reduce out. This 3 right here and this 5, they don't have a factor of x. So you cannot pull, I cannot reduce this. So let me show you. This is an incorrect step, don't do it. Some students will do that. Big error, because it's not a common factor. This is the factor, x minus 5, is protected by parentheses. The only way I can get rid of it is if there's another x minus 5 up top. So let me pull that off. And that is fully reduced. It's simplified as far as we can go. So here's the nice thing, is what we're going to do now is we're going to add, subtract, and multiply and divide. And then when we get to our final answer, we have to check and see, can it be simplified? So we're going to go back to this step. All right, so this is kind of like your last step that you'll do. Okay. Maybe write this one down. All right, we have really 3 steps when we talk about multiplying rational expressions. Or what happens when I multiply fractions? Well, just like we did in the warm-up, you want to factor the numerator and the denominator. Reduce it down. Then reduce out common factors on top and on bottom. That really should say numerator and denominator to be more math appropriate, but top and bottom's fine. And then once you have it all reduced, combine whatever's left over and simplify. All pieces. So instead of multiplying it together, factor first. So let's look at, I usually start with the top one. Notice there's only 2 pieces. If there's only 2 pieces, then you're just thinking, well, what do both pieces have in common? What's the largest piece we can take away from each one? I can take a 2 and an x. And what's left over then is an x plus 2. And here's the nice thing. If you're not sure about your factor, in your head, I'm going to erase this part, but what if you redistribute it? If you multiply it together, you get back to where you started. If you did, then you know you did it. So that's kind of a nice thing about this, is you can check if you like. And then what I do, I just cross out this bottom, just because it makes it easier for me to see. And then let's deal with this denominator. So I'm thinking, what times what gives me negative 12, but adds up to give me negative 4?
Negative 6 and 2.
Perfect. X minus 6, x plus 2. And again, if you FOIL that out, you should get right back to where you started. Okay. And then I'll cross that out. And then go back to the top one, the numerator. What are factors of 18, positive 18, that add up to give me negative 9? So negative 6 and negative 3.
Yeah.
Yep. Because a negative times a negative is how I get the positive 18. And then when I add two negatives together, it gives me the negative 9. So I'll cross that out. And then here, you technically just have a 2x, so that's fine right where it's at. Now, anything on top can reduce out with anything on bottom, because we were technically multiplying straight across. So I see a 2x right here. That 2x is going to reduce that 2x. Are there any other common factors? X minus 6. Top and on bottom. Anything else? X plus 2. Top and on bottom. And if you notice, the only thing that's left over is the x plus 3 on top and nothing on bottom. Now I do want to mention this just quick. There's always something left over. It's never zero. It's never gone. Technically, there's a 1 left over. Right? If everything reduces out, there's always 1 left over. But do I have to put it divided by 1? No. So really, my answer is x minus 6. Now, we're only going to do this one example with multiplying, because when we move on to division, it's one extra step. And then it's the same work. So we're going to do like 2 or 3 more division problems, which is really the same practice as we get here. All right. So, well, remember when we divided fractions? We don't like to think of it as division. I'll just show you this really quick. If I had 1/2 divided by 3/4, we don't like division. We like to multiply by the reciprocal. So instead of doing 1/2 divided by 3/4, we do 1/2 times the reciprocal. Notice how it's the second fraction that's flipped into the reciprocal. The first fraction stays as is. So I'm going to give you a little hint on how to deal with this. And then, by the way, if I was to finish this problem, see how there's a factor of 2 on top and on bottom? And I would multiply across and you get 2/3. So you don't have to write that one. That's just what you've done in the past. But here's a hint. Now, I'll give you a big hint. For your notes today, I want you to write this problem. Okay, write it exactly as it is. Don't do any factoring yet. What I've noticed in the past is students that have tried to do this in their head, when it comes to a test or a quiz, that's where they make mistakes. It's not that they can't do it, it's that they try to do things too fast. So here's my advice for you guys, and it's just one more annoying step. Okay, but I've found success with it. What we're going to do is we're going to take this, and we're going to first change the multiplication, and then you're going to just rewrite the second equation as the reciprocal. You're just going to flip it. And then the first equation doesn't change. if you do this one simple step, yes, it's a little extra work, the chances of error are almost gone. Because now, it's just a multiplication problem. So why don't you guys try what we just did on the last slide now. Since it's rewritten, factor the top, factor the bottoms, and see if you can reduce, and we'll give you a minute to work through this one and see how far you get. Maybe you'll take this value or not. So I teach calculus class, and I have students who are in my calculus class that I had 2 years ago in the class you guys are currently taking. So basically, in 2 years, I'll see you guys again. Or you might get my tires. Anyways, what I've noticed with some of my current students is they're very, very intelligent. They can do this stuff. They could probably do this in their head and get the answer, which is awesome, cool, you have that ability. What I've noticed, though, is they've relied so much on that they haven't practiced the skills of writing and showing their work. And when you get to calculus, that's really what's important, is the justification of your work. It's not really as much the answer, but how did you get to it? And what I've noticed is they have never practiced that, and they're really struggling, not because they can't do it or don't understand it, but they haven't practiced the step-by-step process just of justifying and showing their work. So I figure if I can start making you guys aware of things like that now, you can practice them and become very good at that. So when you do get to calculus, you're going to flourish, and you're not going to struggle with trying to learn some habits that we want you to build from 9th grade on. So anyways, I thought of that when you think about problems like this. All right, so let's factor this top. You should have got x minus 5 times x minus 6, and you can write those in any order, it doesn't matter. The bottom is already factored. We're going to leave that as x minus 6. The top is factored already. And then the bottom here, we get x minus 5 times x minus 7. And then I just cross off the ones that I kind of already used. And now it's that same game. What do we have for common factors? And x minus 5 goes away. And x minus 6 on top and the bottom. And all that's left over then is these two pieces. Sometimes you'll have a lot left over. Sometimes you have very little. There's nothing to reduce the 9x to the third with the x minus 7. That is as far as we can go. All right, so this one, I'll let you know, we're going to have to do some side work here. So this one's about as hard as it gets. And really, the only thing that makes it challenging is look at this last fraction. It's got a 2 in front. It's got an a value that isn't 1, which means there's a strong chance we can't just do this in our head factoring. We have to show a little bit of work. So I actually might put this up here, because if you notice the divide, we are going to have to rewrite it so it's a multiply. So let's say that this is a test question that you guys were asked to do. If I had this image on my screen and I was showing my work, the first thing I would do is change it. And I wouldn't even write the divide part, I would just change it right away. And I'm going to do this just in a separate color. You'll see why in a second. Then all I did was rewrite it, and now it's multiplication. So now we can factor tops and bottoms. So nothing crazy here. This one might be a little tough, just because it's got 2 terms, but anytime you have just 2 terms, see if you can pull out a common factor first. See how they each have a 9x in common? So what's left over then is an x minus 2. Honestly, that's probably the hardest part about this problem is students, this one, remembering that if it has two terms, see if you can pull out a common factor first. And then we get to the numerator of the second fraction, and this is where we just got to show a little bit of work. So I'm thinking of this as side work. We're going to do the box with the circle in it. The number, multiply the two corners. So this is going back to one of the very first things we learned this trimester in chapter 4. You might be really good at this, or you might struggle a little bit, but hopefully this section will help you out. So I'm thinking, what are the factors of 4 that add up to give me negative 5? The only two factors that I know are negative 1 and negative 4. And then we just want to pull out common terms. So if I go vertically here, first two vertically only have an x. And then I can pull out, now here's where I'm thinking, all right, I see a 2. If you don't notice it's a negative, you can catch that negative when you check your work. So that's the benefit about this box method. And then going left to right up on the top, each of these have a 2x in common. On the bottom we have a 1. Now let's say I stopped there. Right? If I don't check, I'm wrong. Because 2x times x is 2x squared, 2x times negative 2 is negative 4x, but 1 times x is not negative 1. So I would have made a mistake here if I didn't remember that that should be negative. And then that makes the last box actually work. So, cross out the top, and then you'll notice unfortunately, have to do the same thing for the bottom one. So why don't you guys go ahead and do the bottom one here, and then see if you can finish this problem. Oh, I've got it squared. There we go. All right, let's take a look. So when I multiply the corners, I get negative 10x squared. Factors are negative 1x and negative 10. And I factor. I get a, and then I'm just going to double check everything works out. So we're good there. I get a factor of 2x minus 1 times x minus 5. Then we get to play our factor game. So we'll reduce out whatever we have in common, x minus 2 in common, 2x minus 1 in common, and x minus 5 in common. And if I look at what's left over, nothing up top. The only thing that's left over is 9x. Now, is that right? Why is that wrong? There should be a 1 in the numerator, and this is one of the biggest mistakes I see. Kids are so used to being like, oh, everything's going from the top. That did nothing to pull the 9x out of the bottom, so this answer is not correct. Remember, you can always put a random 1 up top. So, I just always want you guys to be aware that of these common mistakes. Okay? All right. Like I said, this is about as much work as you're going to have to show. Now, we just got one last way to look at things. And these problems aren't actually that horrible, but they look more intimidating. And for some reason, when students see problems like this, they kind of freeze. Nothing changes. You still follow the same steps and procedures. Instead of division, we want to rewrite this as a multiplication problem. So when we multiply, we keep the first one, change this to multiply by the reciprocal. And then in this case, I don't have any common factors on top or on bottom. Nothing reduces out, which will happen sometimes. So what we do now is we just multiply straight across. 5 times 4 is 20. X to the third times x to the first. Our rule is we add our exponents together when you're multiplying. So I've got x to the fourth over 3 times 7. And that's as far as we can go. Now, let's look at the one that's really scary. This can give some kids some nightmares sometimes. Okay? Here's what I want you to think of. If I read this like a sentence, I have a fraction divided by a fraction. It's the exact same thing as what we just did here. It's a fraction divided by a fraction. It just looks different. So my advice for you, and if you don't have to write this step right here, I would skip this step that I just wrote, but that's what my brain is telling me. Because now, it's in the same form as the problem we just did. So why don't you guys try to finish this problem and see what you get. Alright, so this is what I would do. Change it to multiplication by the reciprocal. And you don't have to do this, but this is the way my brain works. So, isn't 9 3 times 3? And isn't 10 5 times 2? So, I basically factored, maybe I'll just put the x squared there. I factored those, and now I can reduce. So I've got 1 3 on top and on bottom. I've got a 5 on top and on bottom. And I have an x squared. So the x squared is going to reduce out and leave just an x on the bottom. So what's left over then is 3 times 2 up top, which is 6, and then an x on the bottom. That's far. Okay, so division is I'm falling apart here. Excuse me. There we go. I'm sure the people at Zoom are just sick of me coughing right into the microphone, then drinking water right in front of them. I apologize, everybody on Zoom. Okay, our last idea here is add and subtract. And we got just 2 more, these 2 examples, and then 2 more after that. So the rules for adding and subtracting are the same as if it didn't have any variables in the bottom. But our goal is to find a common polynomial denominator. If I'm going to ever add and subtract, I just need to have common denominators. And sometimes it's already given. Sometimes it's not. But once we have the same denominator, you add the numerators, leave the denominator. And we're going to leave the denominator in factored form. And I'll show you what we mean by that and then simplify. I don't even think you need to write this first example down right here. If you did, cool. Maybe in your head, just think, what is it? But we'll have you write the second one down for sure. Like I said, you don't have to write this one down, but notice sometimes the denominators are exactly the same. I'm going to just show one tiny extra step that you hopefully are thinking in your brain. What do we do once we have the same denominator? Well, that same denominator stays, and the numerator is just adding those together separately. But why write that if you can do it in your head? 4x plus negative 3x is 1x over x minus 2. And remember, that x minus 2 is protected. So I cannot reduce an x on top and on bottom here because not every term has the x. All right, this one I would write down. Students sometimes get a little confused because we're supposed to be subtracting fractions. I don't have a fraction minus a fraction. I have a fraction minus a whole number. Well, let's turn that into a fraction. And then our goal is to get the denominators exactly the same. So in this case, I have a 5x to the third, and this is missing a 5x to the third. To get that to become a 5x to the third, we have to multiply the top and the bottom by 5x to the third. Okay. Now, I don't care how you do this. If you want to rewrite this again with it multiplied out, that might be helpful because 3 times 5 is 15. X to the third over 5x to the third. And I'm just going to show you one thing that I probably should have done this earlier. I really don't like subtraction. That subtraction is going to cause us problems in a little bit, so I'm going to make this adding the opposite. So that'll make it look like a negative 3, so that'll be a negative 15. And then you can play that same game. Keep the denominator. But notice here the numerator, I have 2 plus negative 15x to the third. I can't combine those. And there aren't any common factors for me to read these out, so that's as far as we can get. You didn't have to write 2 plus negative 15x to the third. You could have wrote 2 minus. Okay, so that's kind of the real basic ones. Hopefully, you're going to get some friendly ones like this where the denominators are the same. But if they're not, we have to look for what's called the least common denominator. So let's look at these two here. And these will be the last two we do today. I'm going to actually save this one for a little bit later. But notice, right away, the denominators are not the same. And it's a subtraction problem, which I don't love. So, the very first thing I'm going to do is say, you know what, I don't want that to be subtraction. I want it to be addition. But it's going to turn every sign past that opposite. So think of that as a negative x plus a negative 4. All right. So now I need to find that least common denominator, but I need to factor these first. So I'm going to factor out a 3 here. And I'm just going to cross that. And then I'm going to factor this one, and notice this is one of those special patterns. What times what gives me negative 9, but adds up to give me that 0. X minus 3 and x plus 3. So we could get really creative and write over here what's the LCD. But here's the way I think you guys should do it. I need to have all of these pieces somewhere in my denominator. So see how this one has a 3 and this one doesn't? We're going to times the top and the bottom by 3 here. Now, what is the blue denominator missing that the green one has? plus 3. So I'm going to multiply this. I usually sneak it at the end. So I'm going to multiply the top and bottom by x plus 3. Notice how they have the same denominators now? So the next thing I'm going to do is just write that denominator out once. There's my denominator. The top part, though, we've got to do some work. I have to distribute 7. So 7 times x will give me 7x. 7 times 3 is a 21. And then this 3 has to multiply. So 3 times negative x is a negative 3x. And then 3 times negative 4 is a negative 12. Now notice, don't do anything with the denominator. I think this example might show why we just leave the denominator as is. Leave the denominator in factored form. But now up top, we're going to get a new numerator. Because we have like terms. 7x minus 3x, well, that's 4x. 21 minus 12 is 9, positive 9. And then the last piece, we should always think about this. Can 4x plus 9 be factored? Does 4 and 9 have any common factors? No. That means we're done. Okay. Now sometimes we'll get this new numerator that will be able to be factored, so then we have to factor it. And if it has a 3 or an x minus 3 or x plus 3 in it, that could then reduce out. So that's why we leave that as is. All right, last one. All right, so notice right away this is a subtraction. We don't like subtraction. Kind of like we don't like division. Let's make it friendlier by changing this to adding the opposites. So everything in the opposite numerator, not the denominator, just the opposite numerator, changes signs. It's like distributing a negative 1 to everything up top. So now we want to factor the bottom. We got a 2 that can be taken out of the first piece. And then this one, we've got x minus 3 and x minus 1. Our factors positive 3 that add up to give me negative 4. So we just factored the bottoms. And now we get to play that same game we did up top. So I want to look at the difference between these two. And I want to think, okay, this one has a 2 in it. This one does not have a 2. So I'm going to multiply everything up top by 2. But there might be more. So I'm not going to FOIL that out yet. But then I'm going to go ahead and look at the next one. Well, this has a 2. It has an x minus 1. But it doesn't have an x minus 3. I'm going to multiply by x minus 3. And notice how I put that top in parentheses. We're going to have to FOIL that. And we multiply it. So it's a lot of multiplication here. But notice, now my denominators are exactly the same. So I usually write the constant first, and then it doesn't really matter the order. But there's my, what we call the LCD. It's the least common denominator. Now, if you want, you could do this as side work, or maybe we could FOIL it right here. So I'm going to go x times x, which will give me x squared. And then I'm going to go x times negative 3. And then I'm going to do 2 times x, and 2 times negative 3. So all of that green is just FOILing out that first numerator. You could combine like terms, but I'm going to have other like terms that I'll have to deal with, so we might as well wait. But then I have this 2 that's going to multiply everything together. So 2 times 2x will give me a 4x, and 2 times positive 1 is positive 2. And then let's just look for our like terms. So I don't have any other x squared, so I just have this 1x squared. So I've got a lot of x terms. So my x terms, if I take 3x, negative 3x plus 2x, that's going to give me negative 1. Negative 1 plus 4 is a positive 3x. Then I've got a minus 6 and a plus 2. Whoa. Notice how our answer now is a trinomial? We're not done, because we got to go back to the idea of now we have to simplify. So let's think of this new answer. X minus, let's see, is that factorable? Yeah, x minus 1 times x plus 4. Negative 1 times 4 is negative 4. 4 plus negative 1 is positive 3. So we have to factor. Do I have any terms top and bottom that can reduce out? X minus 1. So notice how your new answer may have a factor. And do you see how nice it was to leave your denominator in factor form? That's why we do that. So then what's left over on the bottom is 2 times x minus 3. And all that's left over up top is x plus 4. And then that's our answer. We don't. If you want, you can distribute the 2, but I don't think it's helpful. It doesn't get us anywhere better. All right. What I've seen in the past is multiplication and division and simplifying, kids are really good with it. Addition or subtraction, actually it's subtraction. And you notice how I tried to do more subtraction problems in this? Because that's usually where kids make a mistake. The first thing we did for both of these problems was we changed it to adding the opposite of the numerator. And if you remember that, that'll reduce potential errors. Okay, so your homework tonight is on Delta Math. It's titled Operations with Rational Exponents, Add, Subtract, Multiply, Divide. If you're looking at your textbook at all, it's section 4.8, 4.5. And this is for people who are in class, but if you're coming into Tartan, if you don't use your book, we're gonna do some stuff out of the book, but all the homework assignments are either gonna be Delta Math or a Desmos activity for next week. So we really don't need your textbook anymore. So if that's the case, and you want to bring your Algebra 2 textbook, bring it on Wednesday, and maybe Wednesday afternoon we'll go right to the Media Center and just drop it off. Then it's checked out, you don't have to worry about it, and that's one thing less that you have to think about. If you did not bring your geometry book back either, you can do that at the same time. So those of you who are on Zoom right now, if you're ever coming into Tartan during the week, bring your math book and just drop it off at the Media Center. And that's one less thing to take care of later on. Okay? All right. Last thing is some of you did not do the Chapter 6 test from last Friday. That should be a top priority this afternoon once you have time to do so. Please make sure you get that done. All right. That's all I got. Have a great day, everybody. Adios.